All right, so for this example, we're supposing that we have the given polynomial function, and we're being told that one of the zeros is 1. What are the other zeros? Now, this is an example where you might have graphed it in GeoGebra, and let's see what that looks like. All right, so we're going to graph our function. We've got x cubed minus x squared plus x minus 1. And you can see that this function has only one real root, one x-intercept, and that is at x equals 1. But it's a third degree polynomial, so it needs to have 3 roots. It's just not all of them are going to be real, right? So how do we figure out what the others are? Because we can't find them on a graph, right? And so we're going to use synthetic division. We have no missing terms. So we put that reminder up, no missing terms. So we got our coefficients 1, negative 1, 1, negative 1. We're going to do that synthetic division. All right, and so we see obviously we got zero remainder, so x minus 1 is a factor. So that means that we've got x minus 1, and then of course this is x squared, x, and constant terms. So we've got x squared plus 1. Now, so how do we figure that one out? Well, we can use square root property if we want to. We've got x squared plus 1 equals 0. X squared equals negative 1. Take the square root of both sides. Right? So we can say, let's do this, we can say x squared equals negative 1, and we are going to take the square root of both sides. And then, of course, we get x, and we get, remember when we take the square root of a number, we are going to have positive or negative, and the square root of negative 1 is I. So there we have our other 2 zeros. So I and negative I are the 2 other roots or zeros. Okay, and if we want to, and we already graphed it, so there we go. Okay, so that's all that there was to this one. Now we have another one, similar idea here. We are told that one of the zeros is 2i, and our function is f of x equals x to the 4th minus 16. And yes, you can graph this one to get all of the zeros, so this is really more practice about fully factoring and using synthetic division to do that, because we know another root, don't we? We know that negative 2i has to be a root. But we're going to go ahead and do our synthetic division. We do have missing terms here, so we need to be careful. We've got x to the 4th, no x cubes, no x squareds, no x's, and constant is negative 16. So we've got 2i times 1 is 2i. 2i squared, 2i quantity squared is going to be 4i squared, so that's negative. And then we've got negative 8i, and negative 16i squared, which is negative 1. So there we go. We know that we have it as a root. Now, we also know, because these complex roots have to come in complex conjugate pairs, that negative 2i is also a root, because this now is still a 4th order polynomial. So we've got x minus 2i. That's one of them. All right, so we're going to divide this out, right? Negative 2i, we're going to have 0, 0, negative 4, and 8i, which of course cancel. And so we've got that. So we just showed that negative 2i is a factor. And we're left here with x squared minus 4 equals 0, which is a quadratic that hopefully you know how to factor here, right? Because it's a difference of squares, x minus 2, x plus 2. And those two you would have found if you had graphed it with GeoGebra. So let's just take a quick look at that. Let's see here. All right, so we're graphing x to the fourth minus 16. And so you can see that this only has the two roots, -2 and +2, but it does have two imaginary roots. You just don't see those because they're imaginary. You don't see them when you graph it. Okay, and I think that we're at the 5-minute mark again, so we're going to stop, and we've got just a little bit more to go.